It's the middle of July. It is 100 degrees outside. The humidity is oppressive, and you finally step through your front door into a perfectly crisp, perfectly chilled house. For a lot of us, the intuitive assumption is that the big metal box outside is acting like a reverse oven, manufacturing cold air and pumping it directly into our living rooms. But the laws of physics don't work that way. Cold isn't a physical substance you can create or generate. Cold is simply the absence of heat energy. To cool down an entire house, the central air conditioning system functions as a giant, continuous sponge. For that indoor environment to feel truly comfortable, this sponge has to wring out two very specific things: thermal heat and heavy, sticky moisture. Cooling a sprawling, multi-room home evenly requires a system built for massive, relentless extraction. The entire extraction process starts at the thermostat. Think of this as the brain of the operation. When the room warms up past your target temperature, it triggers the system to wake up. That signal fires up the air handler. Acting as the lungs of your house, the air handler takes a massive inhale, pulling warm, humid air from every room through the return ducts. All that gathered air is pushed to the system's sponge, the evaporator coil. Inside is a specialized chemical called refrigerant. As warm indoor air is forced over the freezing metal, the refrigerant quickly absorbs the thermal energy. But removing the heat is only half the job. Think about a freezing cold glass of sweet tea sitting on a porch in the middle of summer. The exact same physics apply here. When the warm, humid air from your home collides with that cold coil, the moisture in the air rapidly condenses into water droplets, dripping down into a pan to be drained away. Air exiting this coil has been stripped of its thermal weight and humidity, leaving it crisp and dry as it heads back into your living space. Meanwhile, the refrigerant inside the pipes is now bloated with the absorbed indoor heat, and it travels outside to that familiar metal box in your yard. Inside this condenser, a compressor violently squeezes the refrigerant, increasing pressure to superheat the chemical. Then, a massive overhead fan blows across the heated coils, wringing the sponge out and releasing the stolen indoor heat outside. Back inside, the newly cooled, dried air is pushed into the supply ducts, the arteries of your home, and distributed evenly into your living spaces. Inhale the warm, absorb the heat, wring it out outdoors, push the cool air back. This cycle repeats over and over until the thermostat detects the exact target temperature. To cool a large physical space, you literally have to carry the heat outside. This chart compares the runtimes of two different AC systems to show why buying an oversized unit to intentionally cool your house faster is a massive design failure. A system's capacity to remove heat is measured in British thermal units, or BTUs, and you can see here that the oversized unit runs for a very short, truncated period before shutting off. Looking at the gauges on this same chart, the oversized unit hits its temperature target almost immediately, but it shuts down so fast that it leaves the humidity gauge nearly full. The properly sized unit runs longer, emptying both the heat and the moisture. When an air conditioner short cycles like this, it leaves the air full of water vapor. Your house will hit 70 degrees, but it will feel cold, clammy, and uncomfortable. To solve this, newer designs use variable capacity compressors. Instead of a system running at 100 miles per hour or 0, these act like a car's cruise control. They run frequently, but at lower, efficient speeds, often around 70% capacity. This maintains quiet, perfectly balanced temperatures and strict control over the indoor humidity. Because this entire heat extraction process relies on steady, predictable airflow across the coils, restricting that air is the fastest way to break the system. That is why changing the air filter regularly is the single most important maintenance task for a homeowner. When that central system kicks on, you're hearing a relentless, perfectly balanced machine performing a whole house heat eviction.